Hi and welcome back. I'm going ahead in the project of the FRR-33 diversity receiving station, and in this episode I'm starting to work on these two very neat and interesting components that are part of it. The one here on the left is the C974/FRR-33, which is the selector control, and the other one here in the right is the C973/FRR-33, which is the remote switching control. So as you can see, this is the real remote control, and indeed it can be mounted and used far away from the station itself. The unit here actually is the real converter. Indeed, the dial here, the telephone type dial, will generate pulses that are converted inside the unit in appropriate relay switching in order to drive the two receivers that are mounted in the station, as well as the two antenna tuning system. The remote control there, it's just replace this dial and can do the job that do this dial here locally, remotely, using an internal audio frequency amplifier, which give pulses in the input of this unit at 1.1 kilocycle, if I'm not mistaken. We will see later on onto the manual. So I will start with this unit first, since it's really the core of the remote control, if we can call it like that. So here we have some indicators behind this hinged cover. So let's remove that from the bench and open it up and see how it's inside. This is the back of the switch control. There is a lot of connectors which refer to the remote control of each equipment, receivers and antenna tuning system, as well as this terminal strip which receive the signal from a 600 ohm balancer line from the remote control. And there are additional connectors. Actually, I'm not quite sure yet the purpose of all those connectors. We will see later on, with the exception of that is the power connector. So I have removed the screws from the back, loosening the top, and this is how it is inside. Clearly here we have a rectifier. This seems to be, it's a 6082, which normally used for 5Y3. This should be the voltage regulation. You have a lot of relays. All of those are relays, transformers, capacitors, and not sure what is inside here. So let's flip it over and see what is in the bottom. I have removed all the bottom screw, so I can remove that. And would you look at this beautiful device here? It's a sort of rotor. There is a sort of motor over there. Let me see if I can show you. So I'm seeing down there here something that seems to rotate. So perhaps this is the dial conversion. Not quite sure yet. And over there I'm seeing a gear. So I suppose there is a motor, an electric motor down there. There are a lot of capacitors that I will try to get reformed, and hopefully they will came up fine. Otherwise I will have to take care in some way. So let's start with the process of reviving this thing, and I will start exactly from the capacitor with the heat kit capacitor checker. While I was checking the capacitors, the first two, the 26 volts capacitor, are fine. This is also fine, but this is a bit leaky. However, I have seen that they are crossed in polarity. So this is, which is higher terminal, it's connected to the lower one. So I wonder if they are non-polarized, and differently how is in the manual, which let me grab the schematic, report those right there as polarized and connected together. So the sum will be 40 microfarad. So there are some sorry work, but I'm not quite sure. The solder job is really factory style. So, well, I will remove that and check if there is any indication of polarity. Okay, they are non-polarized capacitor, but actually they serves as delay in the relay release. And as we can see here, they are right there, and they maintain the negative, the ground onto the terminal number 10 of the relay over there, in order to have a delay in the switching off. So they are directly connected to 26 volt. So the sum will be 40 microfarad. I believe that I can simply replace with one capacitor and try it. The other one is pretty perfect, but it's only 20 microfarad and I need 40. So I will reassemble the capacitor in place, and I will make some small modification in order to have a 40 microfarad polarized capacitor. Another way might be the use of two capacitors like this, 47 microfarad, and place those with negative sides of both facing together, connecting together, and using only the positive side, having a non-polarized capacitor almost. So I could restuff this, and for sure will be a more pretty job. Let's see how. I already have tested with the capacitor tester with this way, and it's pretty fine. So let's see. Well, I eventually have decided to just place a new capacitor just in order to test the the device, and later on I will restuff with some non-polarized capacitor that I should have in my hand in the near future. So I can go ahead with the test since I have checked all the other capacitors that seems fine. So let's power it up and see how it behaves. Okay, everything is connected to the variac. I'll be monitoring B plus and plus 26 volt. Rising up voltage, it's about 50 volt, and we are seeing rising the DC voltage, the low voltage, 26. So since I already have tested the relevant capacitor, I will not make any reforming weighting for this test. So I'm at 110 volts. This unit is set for 230 volts. So yeah, we are seeing some movement here onto the negative side because we have a swapped lead. Okay, so we are having already B plus at 130 volt. That is encouraging. Okay, I will leave this voltage for a bit, and yeah, let's rise up a bit more. Well, it seems that it's responding perfectly. B plus should be 220 volts. We are almost there. Okay, there is a lamp here that's starting to glow. Let me switch off that. Also channel 4. You can't see that, but channel 4 is barely glowing. Okay, we now should see regulation here. Let me try to reduce a bit the voltage. Yeah, it seems that it regulates. Okay, so we are at 150 volt. So let's rise up a bit more. I'm at 180 volt. The regulation seems quite stable. Let me try to do that. Oh, that is wonderful. Test changed. Let's try one. Wow, unbelievable. Let's try 8. That is fantastic. Test changed perfectly. It responds perfectly. So let's try 0 and 6. We have standby. Let's try 0 and 3. We have also disable. 0 to switch to antenna number 2. Let's try 0.5, and it is switched on. It's perfect. Okay, I am now connected directly to the line. Probably the low voltage will be higher. Let's test Yeah, it's over 30 volts, but there is any load, so 220 volts is perfect. By the way, I was looking at the diagram, and the dial itself is located right here. So if the fact that it's working, it means that the whole electronics is working. And I'm pretty sure that if I will connect the remote control, and if that works, I will have also the remote control working. So that will be the next step. By the way, it's working perfectly. Now it's on remote and does not change. If I put on local, it reacts standby. So it's working perfectly fine, all the function. All channels are changed. I went through all the channels. All channels are selected. So yeah, time to reassemble this. I will leave the cap like that for the moment and take care of the other remote control. This is the actual remote control. So I will give a very quick cleaning since it's full of dust. Here we have the rear connection, the 600 ohm line that should connect with the control that we have seen so far. So let's open it up and see if it works. I'm in the process of the screw removing, and there is a very nasty oxidation down below those washers. Unfortunately, there is no cure for that. So I will spray some WD-40 and see if I can at least stop the oxidation process. Tilting the unit, I have found this beautiful schematic that I don't think there is this schematic in the manual, so might be very handy. So yeah, we have a power supply and an audio frequency amplifier, a relay control, which it is driven by the dial, so which I can't see now. Yeah, that is the dial. So this is the power pilot lamp, and this is the tuning in process lamp, which is right that. And this it is controlled by this relay. So when the control here, the remote control, is driving the station far away, there is a certain delay before the lamp will be off, and this is at least what I have read onto the manual. Indeed, we have several capacitors over there that I suppose they should delay the relay release. This is the inside of the remote control. We have a similar circuit here with the series tubes regulation. This is still set for 150 volt that I will switch. We have a bit of dust here that must be cured before anything else. But all in all, it's yeah, I believe these have a very minor work on, as well as the other components. So give me A quick clean will rise up voltages right with the variac. By the way, let me see down there. Okay. So, yeah, nothing special with the except that this itself it's special. With the inside cleaned and the main switch setting on 230, I'm now ready to try this if it's working. So I will make the setup and check the output here with the scope. So let's do that. Okay, the setup is ready and I'm going to increase the voltage with the variac, and I'm at 50 volt. So, oh, would you look at that? It's already rising up. Is it? Yeah. It's set for 230. So this make me believe that the tubes are almost brand new. So I'm at 70 volts. So we already are having a very high voltage. I'm monitoring right at the output of the 6082, so should be regulated. And indeed it's dropping down now. This is a clear sign that the tubes are glowing. Okay, I'm rising up again and I'm starting to see glowing the lamp. I'm having 170 volts. I'm almost at 160 volt AC. So, well, I'm at full voltage. However, I have noted that this lamp is always on, except in standby position. If I trigger the dial, then we'll switch off, but after just a bit will be on again. And if I go on to the on position, it will remain always on. So that, I believe there is something wrong, so must be checked what's happened. I think there is some leaky capacitor, or perhaps a grid resistor that is open. However, I wanna see with the scope the signal output, the shape of it. Okay, this is the scope monitor, and I'm having pulses. If I go to number 1, 1 pulse. Number 2, 2 pulses. Number 3, and so forth. 5, 7, and so forth. So the pulse generator is working perfectly. I just need to fix the problem with the tuning lamp. Okay, let's try to understand how this relay is actuated. Well, it seems that when the dial is triggered, bring this grid to a positive voltage through this voltage resistor divider, which is right feed from the B+. And this grid should leak the charge of the capacitor over there in order to have the delay. And as soon as those capacitors are discharged, we should have a low voltage onto the grid, and the valve should stop to have flow. to be switched on. So I think that those two capacitors, there is some leakage. The resistor itself, it's fine. I have already measured it. So I really believe that we have a leaky capacitor over there, because I'm measuring high voltage all the time here. So let's try to, let's check this capacitor. Well, I'm monitoring the voltage across the capacitor. This is the input voltage. This is the other terminal of the capacitor, which the C blocking capacitor. It's a 1 microfarad non-parallelized capacitor. It's completely leaky, as well as this one. And yeah, for sure has developed, both have developed an internal resistance that due the very high impedance of the input valve, the grid here is a very high impedance circuit. And by the way, I have also the description of the remote control onto the manual as well. So I need to replace those with a 2 microfarad capacitor in some way. So let's try that. Well, to verify that my assumption is correct, I have just stuck 2.2 microfarad polypropylene capacitor, and as in the manual, it's stated that we should have a delay of about 15-20 seconds. If I give a number here, the lamp is on and monitoring the voltage. Indeed, now it's dropping down. This is the grid voltage. So it seems that we should have a delay. And yeah, and now it's switched off. Let's try it again. Yeah, should need about 15 to 20 seconds again. That is the time that the receiver requires to complete the worst condition channel change. Yeah, so this has cured the problem. That for sure will be not the final fix, but again, just for testing purpose, I will leave like that. I will put in a safe, more safe position and test this one connected to the local control device, and after that we will connect all together to the receiver itself. The setup is complete. We have the 600 ohm line connected. So I have figured out what does mean bay number 1, 2, and 3. Since this remote control can control up to 3 diversity stations, you must select first the number of the bay and then you can give the command. In this case, I have selected right here with the switch that leaves down there, bay number 1. So let's say I want to change channel from 1 to 8. I have to switch to bay number 1 and then channel number 8. And this is changed. Again, bay number 1, and I want to put on standby, and I have in standby. So it's working perfectly. It's a very, very beautiful thing. Can you imagine in the 50s have such remote control that if I don't mistake, should live up to 500 feet, so almost more than 150 meters from the station, with a 600 ohm line, and there is a level adjustment behind the instrument, the remote control there, that you can regulate the amount of signal that is outputted from the remote control to have enough signal to drive this. but it's absolutely perfectly functioning, and with the exception of those stupid capacitors, yeah, everything is fine. So I can now bring back to operating condition, and now it's again on. Let's say I'm gonna change antenna coupler to number 2. So that is pretty functioning. Channel number 1. How neat is that? So at this point I need to connect that to the receiver itself and see if this can control the receiver. Okay, the testing setup is almost ready. As you can see, barely. I have just realized that the station is missing the auto-tune control cable, 5 in total, so it's quite a big miss. But instead of waiting the receiver parts that I will have to source some way, I decided to use some loose connectors, just this kind of pins, and yeah, prepare a testing wire so I can test the whole unit together with the receiver itself. So let's flip it over and see if the receiver actually is controlled by this local control device and the remote one. Okay, so there we have it. I'm in remote control for the auto tuning, local. So if I will change the channel here, I should see the receiver, which by the way is receiving just static, change the channel. So let's try that. And yes, as you can see, it's changing the channel and going to channel 1. Which should be 11.1111. Too many ones. By the way, yeah, and it's receiving just static. Let me put down the volume. So now, if I, as you can imagine, the setup, okay, now it's remote. I will switch the remote control on, and the base selected here is number 3. So if I select bay number 3 with 00 and channel 2, I should have this going to channel 2. Let's try that. And yes, it's going to another channel, and let's see if we'll match to channel 2. Which, by the way, should be also receiving some local station. I have just a piece of wire as antenna. And yes, and as you can see, you may not see, I'm having here the tuning in progress that just went out. Very strong station. So, yeah, it's fully working. Let me put down this. It's fully working. The remote control system is fully working, both local and remote one. And I'm really happy about that. This is the very first time in my life that I see such devices controlling each other. So I think it's good enough for this video, and in the next one I will go ahead with the maybe the antenna tuning system, which requires also the auto tuning control, or perhaps the what is so called AFC device for the receiver. So let's see. Yeah, that's it for this video, and I hope you really have enjoyed these very rare devices in action. And yeah, see you very soon.